All right, welcome to lesson 15. We have now moved on past unit fractions. We are now on non-unit by non-unit. Groovy. Let's get into it. Our first problem is 2/3 of 3/4. Remember, of means? Yes, multiplication. Hopefully you said that. All right, of means multiplication. So here's our fraction model. All right, it's going to look a little bit more complicated as far as the look of it. Will it be more complicated? No. All right, so I'm going to show 2/3. So here's my thirds. All right, and then I'm going to go to the biggest one because that's the easiest. And I'm going to show two of those. All right, I'm going to switch it over to red, and I'm going to show 3/4. So I'm going to show fourths first, and then shade in the 3 out of the 4. All right. 1, 2, 3. All right, so when I say it looks a little more complicated, hopefully you can see what I mean. There's a lot more shading going on, all right? So let's go ahead. We're looking at our double shaded ones. Now, if you're doing this with a pencil, it might be a little bit hard to see. So what I would recommend is maybe using a pencil and then a highlighter, or maybe 2 different highlighters. And that will make it look a little bit better. But anyway, you can still see 1, 2, 3, 4, 5, 6. All right, I double shaded 6, and oh, that looks weird. Let me erase that. And then our numerator is 6, and our denominator is going to be 12. All right. Now, if you notice, 6/12 is 1/2. All right, go ahead and reduce that. Now, if you look at our fraction model, it's not that easy to see that we did shade 1/2. But if you look on the outside, 1, 2, 3, 4, 5, 6. So we shaded 6, and we didn't shade, we double shaded 6, and we didn't double shade 6, right? So it's still half, it just doesn't look very pretty. All right, so our answer to 2/3 of 3/4 is 6/12 or 1/2. All right, let's move on to this one, 2/3 times 2/3. All right, you could also think of it as 2/3 of 2/3. All right, so here we go. I'm going to show my thirds. Hopefully you guys have the hang of this now. All right, but remember, I am more focused on the why than the how, because I know most of you guys will be able to figure this out pretty quickly. But when somebody asks you, well, why? Well, now you can answer them and say, well, this is why. All right, now I'm going to show thirds on the other way. I'm going to shade in 2 of those as well. All right, count them up. I have double shaded 4 of them, and all together I have 9. All right, so our answer is 4/9. All right, once again, if you look at your quick process, right, when you start doing these without models, all right, you're just going to multiply straight across on both. You can only, listen, you can only do this with fractions by fractions, all right? Anyway, so 2 times 2 is 4, and 3 times 3 is 9. Oh, look, we got the same thing. How crazy is that? All right, let's go to this one. Now I'm going to multiply 7/9 times 3/7. Okay, is this even reasonable to do this? Does it make sense to do it? I would say no, because that's a lot of drawing, and it would be really hard to kind of look at. It would be hard to count all of the smaller ones, okay? So we're going to use our 2 strategies from a couple lessons back to solve this, all right? I'll solve it in both ways, all right? If you don't remember, no problem. I will refresh your memory. Apparently this is going to be really big. Okay, so I have my 7/9, okay? I can go ahead and just combine them into one big fraction. All right, I'm going to extend this here times 7. All right? Okay, yes, I know I made a mistake. This is supposed to be 3. Let me change it. All right, here we go. 3. Okay, so we still have our 7/9 on this side, and we still have our 3/7 here. All right, so 7 times 3 is 21. All right, and then we have 9 times 7, which is 63. All right, now this is a pretty big number, but we can reduce. All right, so if you can find the number that goes into both of them, right, then we can figure out what our answer is. Now, off the bat, you know that 7 can go into both of them because look, we just multiplied by 7 on both sides. Anyway, so we can go ahead and reduce by 7, and then we'll get 3/9. And this is actually going to help us with our second strategy. But we're not done because there's another, we can reduce again. We can put 3 into 3 and 3 into 9. So our actual real simplified answer is 1/3. All right? I got smaller and smaller. Anyway, so we'll use this bottom part for our second strategy. I'll put it in red. Okay? So we're going to set it up the exact same way that we did before. All right? But instead of just multiplying straight across, I am going to reduce first. All right? So you can go ahead and put it into one big fraction, but it's a little bit easier for me to just write them out like this. So I notice that 7 and 7 are the same, right? So I can go ahead and reduce. 7 goes into 7 once. 7 goes into 7 once, right? So then 1 times 3 is 3. Oh, look at this. This is just crazy. And 9 times 1 is 9. All right? Now, even though I reduced before, I can still keep on reducing because 3 goes into both of those. And look at that. We still get 1/3. Same thing. Okay? So we're using what we've learned before, even with our multiplying by fractions and whole numbers. We can still use those strategies to help us figure out how to solve these ones. All right? That's the cool thing about math is there's rules. Not necessarily have to memorize all the rules, but make sure you can apply them. All right, here we go. We're going to look at 3/10 times 5/9 and 5/8 times 4/15. And when I say we're going to look at, I'm actually going to only do the first one, and then the second one you can go ahead and pause and solve it, and you'll see that again in your quiz. Now it says use both strategies, but I'm not going to, just because for time's sake, right? I just showed you the last one. You got the idea. All right, so I'm going to go ahead. I'll make it a big long one. So we're going to do 3 times 5 up here, and then we'll do 10 times 9 down here. Now, sometimes I don't love going across, multiplying 3 times 5 and 10 times 9. Because if you notice, 10 times 9 is going to be 90, and that's a pretty big number to be able to figure out which one goes into it. So what I'm going to do, and this is probably my favorite, is I'm going to go ahead and reduce. Now this one is a little bit special because you can actually, and I guess we could have done it on the other one too, but anyway, we're going to do it on this one. I can reduce twice. All right, so if you notice, I have 3 and 9 here. Okay, well, there's a number that goes into both of those, 3, right? So 3 goes into 3 one time, 3 goes into 9 3 times. All right, but look at this. 5 and 10, what? This is crazy. Okay, 5 can go into 10 and 5 can go into 5. So I'm going to reduce twice. This is crazy. All right, 5 goes into 5 once, 5 goes into 10 twice. Look at this. Oh, this is going to be so easy. 1 times 1 is 1, and 2 times 3 is 6. And look, I don't have to reduce again. Bam, there's our answer. Okay, so what I want you to do is you're going to solve C, 5/8 times 4/15. You can use either strategy, okay, or both, just to maybe get some practice on both. But go ahead, do that. You'll see it in the quiz later. All right, problem 4. Enzo. He completes 3/7 of his homework immediately after school and 1/4 of the remaining homework before dinner. He ate pizza, if you were wondering. If that's true, Enzo, that's cool. All right, he finishes the rest of a delicious dessert of chocolate chip cookies that his mom made. Yum. What fraction of his work did he finish after dessert? So we're actually going to show this on a tape diagram this time. All right, so I'm going to make it a little longer than our area models. Woo. Okay. Now, the cool thing about this is we're not actually trying to figure out what the total is, right? It's just trying to figure out what the fraction is. So when we look at our total here, we're not really going to put a number because we're not trying to figure out what it is. So I'm just going to go ahead and say total, T for total, homework. Okay, so his total homework is up there. Now, the units that we're in sevenths, right? He completes 3/7 of that, all right? So I'm going to show 7, sorry. 1, 2, 3, 4, 5, 6, 7. All right, now I'm going to go ahead and show 3 of this. 1, 2, 3. Okay, so this is the homework he did after, I'm just going to say A, after school. It is really hard to write like this. Anyway, okay, you know what I mean. Okay, so after school. Oh, tiny little O's. Whatever. Okay, so now we have this 1/4 of the remaining homework. Okay, now if you notice, we're not talking about sevenths, but if you see this tape diagram, how many is left? Oh, 4/4. What? This is crazy. All right, so we're going to go ahead and show 1/4 as what he completes before dinner. Okay, so this is before dinner. Okay, 1/4 of the remaining homework before dinner. All right, and then how much of his homework after dessert? Well, the rest of it. Right? After dessert. AD. So, our answer is going to be 3/7. Okay? Now, our multiplication sentence is going to look like this. 3/4 of 4/7. Okay, so you might be asking, why are we doing 3/4? Well, because it was, we were trying to figure out after. Okay, we were trying to figure out after dessert. How much did he do after dessert? Okay, and the clue comes here, the remaining. Okay, we're not actually looking at 1/4 of it, we're looking at the remaining. Okay, so then once you multiply across, actually, I'm going to go ahead and reduce because I see a 4 here and a 4 here. I'm going to go ahead and reduce that. Okay, multiply across, I get 3/7. Oh, hey, look, that's the same thing we got before. Woohoo! Okay, last one. This is an extension, so I'll probably go back and look at this, but let's imagine that Enzo took 70 minutes to complete all of it. All right, that's a little over an hour. Where would I put this information on our tape diagram here? Right, the 70 minutes. Okay, so if you look at our tape diagram up here, the TH stands for total homework. Well, now we know how many minutes. 70. So 70 is actually our whole. Okay, so if you are taking notes, you could go ahead and add that to the top of your tape diagram. Okay, so where would I place it? On the top. So how could we find the number of minutes he worked on homework after dessert? So using your tape diagram here, I want you to figure out how many minutes it took for him to finish his homework after dessert. This is going to be on the quiz, so make sure you complete this. All right. Hopefully this all makes sense. If not, we can talk about it.